Hey friends, so I have got an interesting project here. So this particular project is about building modules for learning microcontroller. Here the requirement is quite peculiar. So usually when we learn microcontrollers, we interface switches, LEDs, lights, things like that. So this particular person, they want this to be converted to modules so that learning becomes easier. So the requirement what they have given me is they want standard pull-up configuration switches. Uh, the board should contain four of those simple LEDs, that is LED and a resistor, that is four, and a simple LED chaser, which is four LEDs connected in parallel through resistors and ground, so that whenever a particular pin gets activated, the LED glows up, and a traffic light which consists of three LEDs and a resistor and three pins. Again, similar to LED chaser, but somewhat different. So that's the requirement they have given. The requirement is it should be all on the same board. The pin should be on the left hand side. The pins should be separate for each module. So if we calculate all these things, there are a total of 10 modules, and each module should be bound by a clearly demarcated space. What they mean to say is they want a separate cell screen to be put on each module so that they know what they are using, right? So usually for pull-up, we would use a 10 kilo ohm resistor. For LEDs, somewhere 100 ohms to 220 ohms should be good enough. So that being the requirement, I would want to start working on this, and I would like to join you guys, or you guys join me in this journey. So I'm using KiCad. What I've done currently is I have already created specific footprints for them, and I've stored them. I'll show you guys when we go along. So here is a simple circuit which I have already done, which we can already do again. I'm deleting everything starting from scratch. So I'll take a hierarchy page, put it as switch, and save it. So in the switch, we would require a particular switch and a resistor. So let's take a resistor first. I'll take 1206 resistor because that is pretty big with hand soldering capabilities, uh, and a switch. When I search for switch, push button comes here. I'm taking that. I'm not selecting any footprint because it doesn't directly give us the footprint there. I'm selecting it as it is, and a connector. Connector 1 cross 3 pin. Let's select that and put it here. The pull-up configuration is pretty simple. The first pin goes to the resistor. The switch gets connected to the resistor. The second pin of the resistor comes back to the connector. The middle pin goes to one of the points on the switch or the other leg of the resistor because they are the same, right? The principle being when I connect a VCC or a positive voltage and ground here, because the voltage would be passing through the resistor, the voltage would be passing back here. And when I click the switch here, the voltage drops because ground gets connected, and this pin only sees the ground. So that being the uh, theoretical principle, we have built the module for pull-up switch. So having said that, let's open the PCB layout. Okay, so here first thing is we need to assign footprints. We have not done that for all the components. So I have created this 3-pin module. This is my own module. You would not find that anywhere else. So what I'll do is I'll connect that to the 1x3 pin. The button switch SMD will select uh, the appropriate button, this particular button, save and continue. And once that is done, we can run on ERC. Because this is a pretty simple circuit, there would not be any errors because there is not much of connection here. So let's import that. So we have imported it here. If you remember, one of the requirements was the module should be 20 mm by 100 mm max. So for now, let's select that and keep the module size to be 20 mm cross 100 mm. That's what my board dimensions are currently. So once that is done, let's take this. The other thing was the connector has to be on the left hand side. Perfect. So I would want to keep it like this so that it becomes easier for us to validate the required. I'm just reorganizing this so that it makes sense for us. I usually delete all this extra unwanted requirements. Yep. So having done that, one more thing that we have to take care is the net classes. The net classes, I'm making it pretty big here. The clearance is 0.5, the track width is also 0.5 of an mm. So here when I start routing, it becomes easier for us to get these components routed, right? So once that is done, what I can do is I can simply organize this again. See, what am I trying to do is if I draw a box, whatever I have placed and whatever pins I am trying to place should all be covered within that particular box. That is because once I group this, it draws a box around it, and that what I can do is I'll select both of them and distribute to the left and align to the top. So if you see now, this sits on the top edge of the board, right? And I have clear visibility as to what I can put around it. So because we want a particular particular boundary box around it, I'll take it a bit back so that we know how to place it, right? I changed the grid to 1 mm and brought it back. So because we want 4 of them, what I can do is I'll go back to the root page, press Ctrl D after selecting it, and I'll have the second one, the third one, the fourth one. So what it gave me is it copied the same thing, but I have now 4 different things. This will also help me in making these modules quicker because once I select select it and update the PCBs, I get them here. As you can see, this now are not in the same format as this, right? What I can do is I can simply select one of the components that I've grouped. Go to tools. This is one of the plugins called replicate layout. I select that. Once I select that, it automatically selected SW1, SW2 and SW3 pages. I can click OK. Right. It, what happened? Okay, what it is saying is this particular switch button has more number of texts than what is required. So I can delete that right now. The unnecessary text that I did not want, that is creating the issue. So we can remove it and let's say, let's try again. If you see now, all of them have been completed. They might not be placed right. We might have to turn them, but technically all of them have been completed. So what we can do is we can group them again. If you can see, I'll just hold it here and move this just 2 blocks down from the from the uh, actual first block so that it becomes easier. After that, what I can do is select all of them, align and distribute, and align to the middle so that they all align together. Right now, if we see now, we have exactly 4. Right. So this is for module 1. What I can do is I can even make it arranged to the left of this so that it becomes easier. Instead of that, let me take line to the top. All I'm trying to do is bring them near so that we conserve space. Select everything, align to the left. Yep. So if you see now, 1, 2, 3, 4, we can just put text symbol. We have demarcated each module. SW1. Align to the left and move them somewhat closer here. This would be the switch 2. Switch 3. Let me write it as full. So if we see now, we have demarcated space for each switch, which we can connect and have this, right? One thing which I should have done, but I'll correct that uh, in the footprint editor itself later and bring it back here, is put a positive symbol here and a ground symbol here and output symbol here so that we have all these things, right? So with that said, let's move on to the second component, that is LED. So I'll take another box, LED. Again, I'm doing a basic LED here, 1206 hand mount, resistor again 1206 hand mount, connector, 2-pin connector here. For 2-pin connector, what we can do is we have this particular connector which comes with vertical SMD, which is good enough for us. We'll take that, put it here. The connections are pretty simple. 2 pins goes like this and internally it gets connected. So once that is done, let's move to our PCB reader, update PCB. Pretty simple. So we have done that. What we can do is come back, replicate it, save it. And bring the other components in. Go to tools, replicate layout. Once that is done, the layout is replicated. All I have to do is group them and place them. So for LED chaser, the circuit is pretty simple. We'll copy this. We'll paste it here. We don't require this. We did it. We require a connector of 5. We'll select that later. So the principal being the 1/5 pin is the ground. 1, 2, 3, 4 would be connected to the microcontroller, and they in turn gets activated one by one. Because this is a chaser, we can even remove all this, and at a time only one particular LED would be on. No, there might be multiple LEDs on, so let's keep it. We'll uh, try that in the next one, that is to do with the traffic update PCB. It is giving a error there because we have not put any symbol for that particular connector. 1.5, 1 cross 5, connect 1, 2, 3, apply, import. So that's here. The connection is pretty simple. Let's make sure. So the last module that we'll be working on is traffic. So the traffic lights contains three colors: red, yellow, and green. So we can copy this particular one, paste it here. So we don't require these things, delete it. We don't require this. We don't require this. Require this. Delete it. So what we can do is connection 1.4 because it just contains three colors. We'll put it here. We require a resistor, 1206 resistor. We can put that in parallel to it. So let's say this value is red, this value is yellow, and this value is green. And this value is 100. So that is with respect to the traffic light. So here what we can do is we can bring that, sorry, I forgot to put the connector 1, 2, 3. The reason that I just took a single LED for the traffic controller or traffic light is here we would not be utilizing all lights at once. So it doesn't make sense for us to keep all three resistors and make it simply big or extra material on board, right? So we can just keep one resistor because one of them would be active at a particular time and others would be off at that particular time, right? So align center. Yeah. So we can wire it here. Pretty simple wiring. We can group it. So if you see now, we have all the four modules. In order for me to write it better, I'm just turning it for now. I'm taking this on full screen. Let's say switch 1 to 4 modules with this 1.8 mm, 8, update thickness accordingly. We would want the same thing here, and we do not want Yep. So that completes the entire four modules within the dimension of 20 by 20 by mm. So, yep. LED 1 to 4 modules, LED chaser, traffic light, and switch modules, all complete within a span of an hour. So, with that said, if you know what you're doing, you can accomplish it even faster. I took some time because I had to go back and forth, but yes, this is how we devise modules. Thanks for watching. Have a good day.